Sorry. Is there any way?
We could do like a few of the test problems on
Yeah.
the previous test.
Yeah. Are there any questions? Yeah. Do you have some questions?
Yeah, I was just wanting to like do a few of them. I'm looking at, test one in the spring of 2022.
Okay. What's it? You'll have to sort of read the problem to me.
Okay.
All right, sorry. This is test 1, spring of 22.
Yeah. It is, it's question number 3. It's a force diagram.
Okay.
It's 10 newtons to the right. And then it's a 5 kilogram box.
10 newtons is acting on the box.
Okay.
Yeah. And then 12 newtons this way. And then positive direction this way. And then it's number 3, it says if the velocity at this moment is positive 6 meters per second, is the box in the process of A, speeding up, B, slowing down, or C, maintaining equilibrium?
Okay. So, what does equilibrium mean?
I mean, it's the same.
Okay, so it's okay.
Anyone? Equilibrium?
The forces are equal, it stays.
Okay, so total force is 0. Or hint, Newton second law. If the total force is 0, what else has to be 0? What was that, Jennifer? Oh, the action one, that's third. Second's the equation. What I have labeled as the most important equation in all of physics.
That's equilibrium.
That's the one. So if the total force is 0, what else has to be 0? Yes. Vector. And if the acceleration is 0, what else also has to be true? Think about what the formula for acceleration is, or the math definition.
Velocity equals.
Changing speed over changing time.
Vector acceleration.
Changing velocity.
Yeah. So if acceleration is 0, it has to be 0?
The velocity.
Not the
Not
velocity.
the velocity. The time.
No.
Force?
Say it again?
Force?
Oh, well, we already had that one. You said change in velocity over change in time.
Yes.
So if acceleration is 0, if I have a fraction equal to 0, what has to be true? Or give me an example of a fraction that's equal to 0.
The whole thing would be 0. Or the fraction would be 0.
If the fraction is 0, what has to be true?
Like, maybe like 1.
Say it again?
No. That's fine. Just kidding.
All right, so anything divided by itself is 1. We got that. So how do you get 0 from a fraction? Ooh, divided by 0. The math people haven't figured out how to do that yet. They claim it's impossible.
Divided by the same. Yeah.
Not that, that'll get you 1.
0 divided by
The numerator is 0.
the numerator.
So if acceleration is the change in velocity over change in time, if acceleration is 0, what is equal to 0?
Velocity is equal to.
That's what you said before. It's not the velocity. That's not the numerator is not velocity.
Can you say that one more time?
All right, acceleration, change in velocity over change in time. It's equal to 0. As Angie said, if a fraction is equal to 0,
So change of velocity is 0?
yes, that's it. It's the change in velocity, not the velocity itself.
Oh, okay.
Because I've asked several questions on various things where that the velocity doesn't change, but it's not 0. Acceleration can still be 0, as long as the velocity is constant. So the change in velocity is 0. And again, the vector symbol over the 0 is just, it's called a 0 vector. It is there for math reasons. So there's no change in velocity, acceleration is 0, total force is 0. If any one of these is true, the others are true. All right, so down here, I have velocity here. Is this in equilibrium? Is the total force 0?
No.
So we've eliminated part C already, because the C was maintaining velocity in equilibrium or something like that. What is the total force?
-2.
Yeah, I got -12 plus 10, -2, or I have a vector that's like 12 in the negative direction and then 10 in the positive direction, and my resultant is a vector from where I begin to where I end. That would be 2. Left, with -2 newtons. So now I'm left with, I have a positive velocity and a negative acceleration. What is that going to cause? If one of them's positive and one of them's negative, we've narrowed down to either speeding up or slowing down.
Slowing down.
Yes, opposite signs, they are slowing down. So was that A?
B.
B. Another way of looking at this, the exact same thing. It is going, so I have a, well, actually, that's not, the acceleration is not -2, that's the total force. What is the acceleration, by the way? If I have total force of -2 newtons acting on a 5 kilogram mass, what is the acceleration? Oh, let's pick somebody. Wrong one. Leslie. Oh, no, sorry, Juliana's closer. Juliana.
What was the question? Velocity?
What is the acceleration? We have a total force of -2 newtons acting on a 5 kilogram mass. What is the acceleration? Or how would you find it? Leslie?
What was the question?
We have a total force acting on this box of -2 newtons, acting on a 5 kilogram mass. The question is, what is the acceleration of that mass? Or how would you find it? Angie?
Would it be -2 divided by 5?
Yeah, -2/5. Go ahead, the whole thing. Let's not lose 3 points. Units.
Sorry?
What would units be?
Oh, meters over second? Squared.
There you go. All right, so the total force is equal to mass times acceleration, newtons second law. We have -2 newtons. is equal to 5 kilograms times acceleration. The math problem we have here is -2 is equal to 5a. That's the math problem. We need to get a by itself, so you divide by 5. Angie liked the fractions, so she left it in fraction form. -2/5, and then meters per second squared, or newtons per kilogram if you like. And for the decimal fans, -0.4. So, looking at this from another point of view, if I had, a time and then velocity, so that was 6 meters per second, +6, and this is at time 0. I know that the acceleration is -0.4 meters per second squared. In other words, my acceleration is -0.4 meters per second, which means my velocity is going to change by -0.4 meters per second each second. So I would just subtract 0.4 after 1 second, it's now 5.6 meters per second. After 2 seconds, (5.2). After 3 seconds, 4.8, and so on. Therefore, if you just look at the numbers, you're going 6 meters per second, then 5.6, then 5.2, then 4.8, definitely slowing down as you get closer to 0. Any follow-up questions to this problem or other questions?
Did you have one about this one? Professionals?
No, I haven't.
You're good with this one? On Venus, I don't know if you wanna write this down.
On Venus?
Yes.
Okay.
This is question 20 on the same test, spring 2022.
All right, so this was spring 22, problem number what?
20.
Number 20. So we're on Venus. Okay?
2.55 kilogram ball is thrown straight up into the air at an initial speed of 3.87 meters per second.
3.8?
3.87.
87.
Yep, meters per second at time of release. When the ball was thrown, it started from rest in the hand and was moved straight up at a constant acceleration for 0.42 seconds. As usual, ignore air resistance. And then it says, what is the weight of the ball?
So we have a 2.55 kilogram ball. It starts at rest and thrown. Then it's in the hand for basically being thrown for 0.42 seconds, at which point it's released going 3.87 meters per second.
Mm-hmm.
Okay, and the question is, what's the weight of the ball?
Yes.
How do you find weight?
mg.
So we take my mass, that's given. Multiply times the acceleration to gravity on Venus, which is
Which is 8.87 meters per second squared.
and multiply. I assume there are multiple parts of that problem?
Yeah, there's just 3 more.
Okay, so the first part only cares about what the mass is and the planet.
22.61. And the units would be kilograms?
No. I'm gonna overreact. No!
Okay. Jesus, what is the weight of the ball? No.
Yeah, kilograms is not a unit of weight.
Not anymore.
It is a unit of mass, despite what they say over in the life sciences. Or Europe. It's like acceleration. I mean, in physics, they're very specific meanings.
Okay. We have 22.55 kilograms times 8.87 meters per second squared.
Yep.
Nothing cancels out,
Okay,
so. Is it kilograms meters per second squared?
that, I would accept that.
Okay.
What is the kilogram meter per second squared?
Oh, do something.
There is a one-word unit.
Was it the P?
Nope. Begins with an N.
Yeah.
N. Somebody just said it?
No, Newton.
Yeah. Newton.
Duh.
The 22.61 newtons. And I will tell you this, if I ask for the weight of something, if you love doing the math, have at it, but there's no reason to put this in terms of pounds. Some people seem to feel that, from the past, some people seem to feel that when asked for a weight, I wanted pounds. Newtons is perfectly acceptable for units of weight.
Okay.
Newtons is a unit of force, weight is a force.
My brain just likes to like look at kilograms and then meters per second squared, try to cancel them out, and then like end up with that. But you
Yeah,
said
so-
you would accept that.
Kilogram meters per second squared is correct.
Correct.
That is by definition a Newton.
Okay, and then what is the acceleration?
So, and also typically, if you have the wrong units, you have units, but they're wrong, I'll take off 2 points. No units, take off 3 points. If you use kilograms as the unit of the weight, I will take off 3 points. Although I'm always tempted to take off more, just chocolate scars.
No, yeah, okay. I'll remember that.
Those chocolate scars really weighing me down. All right, do you want the rest of the problem?
Yes.
Okay, what's the next?
What is the acceleration of the ball?
Okay. Well, I know what the initial speed. I assume we're talking about the acceleration as it's being thrown.
It just was, what is the acceleration of the ball?
Okay, I assume as it's being thrown. then.
Yes.
So I'm going from 0 meters per second to 3.87 meters per second in 0.42 seconds. How do you find acceleration?
Force equals mass times acceleration. You use that?
Not the easiest one here, especially since I gave you initial final velocities at time. This formula that
Change
you,
in velocity over change in time.
there we go. So change in velocity over change in time. And so I got 3.87 minus 0 over 0.42, and that gets you probably somewhere around 8-ish. Whatever that number is. I'm gonna put 8 meters per second squared for now, unless somebody corrects it.
9.2
9.21. 21.
meters per second. And then what is the total force on the ball?
All right, total force on the ball. So now Newton's second law. Because that's the total force is equal to mass times acceleration. I do want to point out one thing here. Acceleration is a vector. I'm just going to make up positive so that we're good there.
Okay.
Now we use this. I know the mass is given, the acceleration we just found. Now, it came out with a different number, then, just keep working through it using the number that you have. That way you can get full credit for this and I only take off for that. And so this becomes 2.55 times 9.21, which is something spectacular.
23.48.
Thank you.
Yeah.
Is the last question, what is the average force that the hand exerts?
On the ball.
So as it's being thrown upward, what are the forces acting on the ball? This is while it's being still in the hand, being thrown, tossed up. Name of the force? That's a unit.
No. Not gravity?
Would it be weight?
Yes, weight. Or force due to gravity. Again, gravity is a huge topic of which we're studying just tiny little parts of it. All right, so we have weight acting down. What else is acting on the ball as it's being tossed upwards?
Not your resistance, does it?
Correct.
Force of Venus? No.
Okay, the weight. Which we already found to be 22.61. Why is the ball going up at all? Say it again? Yeah, what force? Yeah, it's a normal force that the hand exerts on it. So I have a normal force acting up. So I know that the total force, that's what we just found out, the total force is 23.4 newtons. That's my total force. I know that's got to be made up of this normal force acting up and this weight acting down. So what does this need to be so that the total is this?
You just subtract it. So 0.8 newtons.
So if that's 0.8 newtons, so if I have 22 newtons acting down and 0.8 newtons acting up, do I have a net force upwards? If I just gave you that problem and said, what's the total force?
You said, do we have a force acting?
So if this is 0.8 newtons up and 22 newtons down, is that the net force is it up or the net force down?
Down.
Down, except we know it's being thrown upwards. So not 0.8.
So it's not.
Well, up is positive. So y minus 22.6,
Okay.
1 is equal to 23.40. That's the math problem. If you want to say you're subtracting them, fine, but it's this minus the negative of that. Or if I'm just looking at the numbers as is written, then add them. So 46.01.